Good morning, guys. In case you're wondering, this is only my third attempt at this video. We'll see if it works this time. Today, we are talking about ratios, and a ratio is a comparison of two things. It could be hot to cold, yes or no. Classic example of a ratio would be there's 5 boys to every 3 girls in a class. But a ratio just compares two different things. We can write a ratio 3 different ways. We can write it with a colon, we can write it with a fraction bar, or we can write it using the word 2, but it doesn't matter which way you write it, we read them the same way. These are all read as 4 to 5, 4 to 5, 4 to 5. So we say the word 2 for a ratio regardless of what form it is in. So these are all 4 to 5. So it says write each ratio the other two ways. This uses the word 2, so I need to use a colon, 327, and I need to use the fraction bar, 327. This is a fraction, so my other two ways to write it would be 529, 5 colon 9. And last but not least, this is 6 colon 5, so I could also write it as 625 with the word 2, or 6 fraction bar 5, which is 625. But those are those are the 3 ways for writing ratios. That's the main point of the slide, is just to show you the different ways we can write a ratio. Next, I have a survey of a class's favorite type of ice cream, and we need to write some ratios depending on what the question is asking us. This first one says, what is the ratio of chocolate to vanilla? So the way we do this is we find the chocolate votes. There's the chocolate votes. That's 7. We find the vanilla votes. That's 11. And we write it either using the word 2, a colon, or a fraction bar. I'm going to write the word 2. Doesn't matter. It's whatever one you pick. The next one says vanilla to chocolate, which is kind of similar to the one above, but the point I'm trying to make here is it matters what order it comes in, okay? So if the word chocolate comes first, the chocolate votes comes first. If the word vanilla comes first, the vanilla votes come first. So order is important with ratios. You have to write it in the same order as the question. I used a colon this time. Did I have to? No, I can use any of them interchangeably. So I can use a colon, the word 2, or a fraction. I'm going to kind of change it up for each one just to remind you that there are more than one way to write a ratio. Strawberry to cookies and cream. Strawberry is 8. Cookies and cream is 5. So I'll write that 8 to 5. The next one says vanilla to chocolate and strawberry. Well, let's do the easy part first. Vanilla is 11. The 2 tells us where we're going to put our colon or where we're going to write the word 2. So maybe I'll change it up. The word 2 tells us where either it's going to be a colon, the word 2, or a fraction bar. So the word 2, I don't know why I drew it like that for. I'm going to start over. Sorry, guys. 2 tells us to either write a colon, to write the word 2, or to draw that fraction bar. So 2 right here, for all these, 2 tells us where to put that colon. It says chocolate and strawberry. If you have the word and in a ratio, that tells us to add those 2 together. So chocolate is 7. Strawberry is 8. 7 plus 8 is 15, and that is your answer. So you only write the colon, you only write the word 2 or the fraction bar once, just once. And if it has the word and, then you combine the other votes. Cookies and cream to all votes. Cookies and cream is 5. There's my word 2. So I'll write the word 2. And this is all votes. And a common mistake kids make is they add up chocolate, vanilla, and strawberry and call it quits. No, that's not correct. If it said cookies and cream to all other votes, you would add these 3 together. It says all votes, so we want to add all 4 of them together. 7 plus 8 is 15. 15 plus 5 is 20. And 20 plus 11 would be 31. It says chocolate and vanilla, so that and tells us to add. So chocolate is 7, vanilla is 11. So 7 plus 11 would be 18. We have the word 2, so we write the 2. And then we have strawberry and cookies and cream, which would be 8 to 5, or 8 and 5, which would be 13. So that's how you write ratios when given a table. Should be pretty straightforward. Just remember the key points are the word 2 tells us to either put a colon there, the word 2 there, or a fraction bar there. And then the word and tells us to add those other ones together. All right. Now let's look at a table of Braves and Yankees. It says Braves wins to Yankees losses. Let's find the Braves. Let's find the wins. The Braves would win 22. Let's write this one as a fraction. We haven't used that yet. Fraction. And the Yankees losses 7. Braves wins to Braves losses. Braves wins 22. Strong colon. Braves losses would be 9. Braves wins to Braves games played. Braves won 22. Braves games played 31. And I'm not going to leave it there. 31 is correct. How? What do you guys think? I know you can't really answer me, but it's like Blue's Clues. What do you guys think? How did I get 31? How did I get 31? Okay, that's enough time. If the Braves have won 22 games and they have lost 9, how many total games have they played? Well, 22 plus 9 would be 31, and that's where I got 31 at. Yankees losses to Yankees wins would be Yankees losses is 7, Yankees wins is 15. It'd be 7 to 15. And finally on the slide, Yankees losses to Yankees games played. Yankees losses 7, Yankees game played. We have to add those together, 22. 7 to 22. So that's a second example of how to write ratios given a table. Now let's talk about equivalent ratios. We have dealt with equivalent ratios this year without really realizing it. Equivalent ratio, since you can write a ratio as a fraction, is the same as writing an equivalent fraction. So if you guys look here, 3/5 is the same as 6/10 because I multiply both the numerator and the denominator by 2. And I can write it, I can multiply both by 2, I can multiply both by 3, I can multiply them both by 4. Doesn't matter. We did this type of process when we worked on adding and subtracting fractions. So that is how we write equivalent ratios. So it says write an equivalent ratio, or write 2 equivalent ratios. So let's start with the fraction one. That's the easiest. If you want to write an equivalent ratio, all you have to do is multiply the top number and the bottom number by the same number. So I could say, hey, if I multiply both by 2, I'd get 6 over 22. That's one equivalent ratio. And I can multiply them both by 3. That'd be 18 over 33. So here are 2 equivalent ratios. Do you have to use 2 and 3? No, but I like to use the smallest number possible. Some other easy ones would be maybe multiply them both by 10. That'd be 70 to 20. Or maybe multiply them both by 11. 77 to 22. It doesn't matter. It doesn't say make them a specific equivalent ratio. It just says write 2 other ratios that are equivalent to the one given. And if you think back to what simplifying fractions mean, if I simplify this fraction or simplify that fraction, they will both simplify down to that fraction. Let's pick something random. Maybe multiply them both by 7. That would give us 28 to 21. And let's multiply them both by 12. That'd be 48 to 36. So key point here is if you are given a ratio and you want to write an equivalent ratio, all you have to do is multiply both numbers by the same number to keep it equivalent. Whatever we do to one, we have to do to the other is the key thing here. I picked random numbers. Doesn't matter what numbers you pick. I would pick easy numbers like 2 and 3 or 10 and 11. I would not pick 37. It'd work, but it'd just make your life a little bit harder. Right. Now it says choose all of the ratios that are equivalent to 6 nines. So let's see if we can do that. All of the ratios equivalent to 6 nines. Key thing is to remember my 6 comes first. So the way we do this is how would 6 become 18? Wouldn't we have to multiply it by 3? And our key thing from our last slide was they're equivalent ratios if I multiply both numbers by the same number. So if I look right here, how does 9 become 12? Does 9 times 3 equal 12? No. So that's not an equivalent ratio. Not at all. So let's do 6 9s here. How does 6 become 12? Times 2. How does 9 become 18? Times 2. That's true. So that's an equivalent ratio. 6 to 9. Right, Shaggy. This time it gets smaller. So not only can we multiply both numbers by the same number to create an equivalent ratio, we can also divide both numbers by the same number to create an equivalent ratio. I can divide by 3. I can divide by 3. And 6 divided by 3 is 2. 9 divided by 3 is 3. There we go. Let's write down my ratio again, 6 to 9. How does 6 become 24? Times 4. How does 9 become 45? Ooh, isn't that times 5? And since those are not the same numbers, that is not an equivalent ratio to that. Okay, let's write 6 over 9. And I'm going to stop right here. I'm not even going to spend time on this one because look at my fractions. Here my numerator is greater than my denominator. Here my numerator is less than my denominator, so they can't be equivalent. If I flip-flopped it to 9/6, that would be equivalent, but this is not. Let's write 6 9ths again. How does 6 become 42? Times 7. 9 becomes 73 times 7. Those are the same. And 6 and 9. 60 and 90, I can definitely multiply both those by 10 to create equivalent ratios. So it'd be 60 and 90. So key thing is if you multiply both numbers by the same number to get a new number, that's equivalent. If it's different numbers or if it just doesn't work, that is not equivalent. So I had 4 equivalent ones here. If I look over here, 8 to 10 times 10 times 10, that one's good. 8 to 10 times 2 times 2, that's good. 8 to 10, ooh. Hopefully we can see that this is close. It's just going to be flip-flop, so it's not good. 8 to 10 would be times 7 times 7. Ooh, is 10 times 7 80? Nah, not good. Write it as a fraction, 8 over 10. I could divide both by 2. 8 divided by 2 is 4. 10 divided by 2 is 5. That one's good. 8 to 10. I could times that by 5. I could times that by 5. That is good. And 8 times 11 is 88, but 10 times 11 is 110, not 111. So that one would be incorrect. Okay. I think we have 2 or 3 slides left on this video for today. This says there are 36 performers in a dance recital. How the ratio of men, I'll read that again. There are 36 performers in a dance recital. The ratio of men to women is 22 to 7. How many men are in the dance recital? So this is tough because a ratio compares 2 different things. But this question is asking about 3 things. It's asking about men, it's asking about women, and it's asking about overall total performers. So when you have problems like this, I highly recommend writing it out using the words they give you. And what I mean is 2 men to 7 women. We want to know how many men are there if there's 36 performers. There's a couple different ways to do this, but let me ask you this. Forget about the rest of the problem. Forget about that. Just look right here. 2 men, 7 women. If I have 2 men in a dance recital and 7 women in a dance recital, how many total performers do I have if it's just 2 to 7? Wouldn't that be 9 performers? Well, now we have performers, and we're comparing it to performers up here. We need to somehow multiply 9 to get 36 performers, because that's what the question is asking. How do we get from 9 to 36? Well, the only way to get from 9 to 36 is to multiply that by 4. Well, if I do it to 1, I have to be fair and do it to the rest. Times 4 times 4, all one big line. That'd be 8 men to 28 women. Now to equal 36 performers, which makes sense. 8 plus 28 is 36. So to answer my question, how many men are in the dance recital? The answer would be there are 8 men. Once again, I did that by adding my men and women to find my total performers. Once I know how many performers were in my initial ratio, I can multiply 9 by 4, to get 36, and I just kind of work backwards from there. Okay, last one. The ratio of baseball players to football players at SVMS is 4:8. Please check all the statements that are true. So baseball to football. So we have 4 baseball to 8 football. So let's look. There are 4 football players for every 8 baseball players. No, that's flip-flop. Wrong. There are 16 baseball players for every 32 football players. Well, let's look. If I had 4 baseball and it became 16 baseball, what would I have to multiply that by? 4. Multiply this by 4. That'll give me 32. That'll give me 16. 16, 32. That's a correct statement. Next one says, there are more football players at SVMS than baseball players. 8 to 4, true to me. If there are 40 football players, there are 20 baseball players. Well, football, and if you be careful because I flipped the order, we have to look at the words. We're talking about football here, we're talking about football here. What do you have to multiply 8 by to make it 40 times 5? What do you have to multiply 4 by to make it 20 times 5? So be careful there. Be careful. And last but not least, if there are 36 kids, 16 of them should be football players. So this is like the dance performer recital question we had before. I don't have kids in my ratio. I have football players and baseball players. Well, if I have 4 kids playing baseball and I have 8 kids playing football, wouldn't that mean I have a total of 12 kids? And my problem states I have 36 kids. How does 12 become 36? By multiplying it by 3 here, you get 36. If I multiply this one by 3, I have to multiply it all by 3 times 3 times 3. That'll give me 12 baseball and 24 football. And let's check that back to our original statement. It says if there are 36 kids, 16 of them should be football players, and not quite the case. All right. So hopefully this helps. Please, whatever day this video is for, I don't know, I'm working advanced at this point. Please do your work that day. Do your best. Email me if you have questions. Contact me on Canvas. Message me if you have any questions. Rewatch this video if you have questions. But besides that, have a great day. Enjoy your time. And I look forward to talking to you guys again soon. See you.